In our last computational topic for this unit, we're going to talk about multiplying polynomials. And we're going to use the model of finding the area of a rectangle to illustrate this. If I say from here to here is 2x, and that from here to here is x, and let's say this is 5, and this is, I don't know, let's call it 4. We know that to find the area of a rectangle, we multiply length times width. So if I find the area of this rectangle, I have found what 2x plus 5, a polynomial, times x plus 4, another polynomial, is. Some beginning algebra students will look at this and say, well, of course, it's 2x squared plus 20. But that is not right. And very soon you will see why in our illustration using the area of a rectangle. So if up to this line is 2x, then that means down here would be 2x also. And this part would be 5. And I can extend this line over here, meaning that from here to here is x, and from here to here is 4. So I have divided this rectangle into 4 smaller rectangles that I can take the area of using the parts of the polynomial. In other words, 2x times x is 2x squared. Remember, 2x times x is 2x squared. Don't forget that now that we're in the process of applying it. I can also see that 2x times 4 is 8x, and 5 times x is 5x, and 4 times 5 is 20. So if I add up the areas of these smaller rectangles here, I will have the product of 2x plus 5 times x plus 4. And we can see that that is 2x squared plus 8x, although that 8 is a little hard to read, plus 5x plus 20. And clearly I can then combine the like terms and get 2x squared plus 13x plus 20. Notice, remember we thought it was going to be, or some of you may have thought it would be just 2x squared plus 20, but that would have left out this entire area and this entire area. So you may ask yourself, okay, I don't think I'm going to want to draw a rectangle for every single one of these problems. And you're right, there is an easier way to do it than that. And basically you can think about this as the superdistributive property. In other words, I have to distribute the 2x, or all of the terms of the first polynomial, this being the first, over all of the terms of the second. So what I get when I multiply the 2x times the x is 2x squared. When I multiply the 2x times the 4, that's the 8x. When I then go back to multiply the second term of the first polynomial, 5 times x gives me 5x. And 5 times 4 gives me 20. So that's the first, all of the terms of the first polynomial by all of the terms of the second polynomial, and then combine the like terms. So let's write down, to multiply a polynomial by a polynomial, the first thing you want to do is distribute all of the terms of the first polynomial polynomial, I'm going to squeeze this in here, nomial, you know what I mean, over all of the terms of the second polynomial. If there's more than 2, you just have to multiply 2 together and then multiply it by the last, just like you would with numbers. The second thing you have to do after that is combine like terms. One thing that sometimes beginning students confuse, because it's a lot to keep in your head, is you have to remember that this first step involves, it means distribute means multiply. And the second step, when you're combining, you're adding. So let's practice with a couple examples. Let's say, I don't know, 3x minus 5 times 2x plus 7. This is the first polynomial, and this is the second polynomial. So when we say we're going to distribute all of the terms of the first polynomial over the second, we're going to begin. Here's the first term of the first polynomial is 3x, so I'm going to distribute it or multiply it by the 2x. Don't forget, 3x times 2x is 6x squared. I'm not finished with 3x though. I now have to multiply it by 7, and that gives me 21x. Now, here, don't forget the sign. This is negative 5 times 2x. That gives me negative 10x. And negative 5 times 7 gives me negative 35. Step 1 is complete. Now we have to look and see if we have like terms, which we do. Positive 21x minus 10x. So when I combine these, I get 6x squared plus 21, plus 11x minus 35. You may find at times, even in R, that these are displayed vertically instead of horizontally, like I just showed you the problem in the terms of 3x minus 5 times 2x plus 7 horizontally. But sometimes you might see them shown vertically. In other words, 3x minus 5 times 2x plus 7, and you can tell it's multiplication because if it were addition or subtraction, they would have that sign here. And this works just like if we were doing multiple digit multiplication with numbers. We'd multiply the 5 times the 7 first, then we take the 7 times the 3x, and that gives us 21x. And just like if I were doing multiple digit multiplication, I would then move over to the 2x. I'd say 2x times negative 5, and just like here, oops, I'm going to run out of room, negative 10x, and 2x times 3x, which is 6x squared. Notice I'm getting the same answer. I have 35 here, I have 11x here, and I have this is supposed to be 6x squared. Except I just caught a sign mistake, and that is that 7 times negative 5 is negative 35. So let's not lose the details with the big concept. I want to show you now also what it looks like if you are using longer terms, because there is a way to do this that, I don't know, I think that it helps keep your terms straight. So let's just say I have x plus 7 times 2x to the third minus 4x squared plus 5x minus 4. I still want to multiply each term of the first polynomial by each term of the second, so I'm going to distribute. X times 2x to the third is 2x to the fourth. X times negative 4x to the second is negative 4x to the third. X times 5x is 5x squared, and x times negative 4 is negative 4x. Now when I get to distributing the next term over all of the terms of the second polynomial, there's a little way to do this that I think helps keep your work straight. 7 times 2x to the third is 14x to the third, and I'm going to line it up with its like term. Just like if we were adding tens, we would put tens over tens and hundreds over hundreds and so on and so forth. So I would encourage you to do this with the longer problems. 7 times negative 4x squared is negative 28x squared. 7 times 5x is 35x. And 7 times negative 4 is negative 28. When I add up everything, I've got negative 28, I've got positive 31x, I've got negative 23x squared, I've got 10x to the third, and I have 2x to the fourth. So that's how I would go about multiplying those. There are also two convenient quadratic equations in your homework tonight, and I'm going to do an example of one that's like that. We're going to spend more time on this tomorrow, but x minus 3 times x plus 7, hopefully I have room on my little screen, minus x plus 1 times x plus 5 equals 0. So I have a polynomial times a polynomial here, so we're going to do what we just learned how to do. X squared plus 7x minus 3x minus 21. Ooh, this is tricky. I'm going to put this in parentheses. Minus x squared plus 5x plus x plus 5 equals 0. Next line, x squared plus 4x minus 21 minus x squared plus 6x plus 5 equals 0. Now remember, when there's no number here, I need a 1. The positive one here leaves these the same when I take them out of the parentheses. By the way, this is a review of subtracting polynomials in here. Minus x squared minus 6x minus 5 equals 0. What makes this a quadratic equation are these exponents of 2. It's a convenient quadratic equation because when I combine these like terms, the quadratic terms go away, and I'm left with 4x minus 6x, or negative 2x, and negative 21 minus 5, or negative 26, equals 0. I need to get my numbers on one side and my variables on the other. And when I divide by negative 2, I get x equals negative 13. More of this tomorrow.